Right, in this biomechanics session we're going to be looking at levers, the basic structures that allow movement of the human body. There are three types of lever, but before we get to there I want to look at the symbols that denote the different sections of the lever so they can make more sense. And obviously the lever itself we're going to be looking purely at diagrammatic form today. So central to the lever, other than the actual lever itself, is this symbol, a triangle. Now this denotes the fulcrum, okay, the pivot or the basis about which the lever will move. The next thing we're going to look at is a square. Now that denotes the load, or sometimes it might be referred to as the resistance. And then finally we have an arrow. Okay, now that can go one of two ways. Okay, there's not two arrows, but there's going to be one arrow on there, it can go one of two ways. And that denotes the effort, okay, where the effort is being applied in order to get the lever to move. So these symbols are really important. They're the symbols that we're going to go through now, and hopefully then enable you to remember the key aspects of each lever and where we find them on the human body. So, first lever. First lever is known as a first class lever. Okay, that will give you a clue for the next two. And so we have the lever itself here. And what I always try to do, and what I would really, really encourage you to do always, is whichever lever you're drawing in any exam or any point, is once you've drawn the lever itself, that you identify where the fulcrum goes, and that just makes it a little bit more clear. It just clicks thingy. Okay, so in the first class lever here, the fulcrum is in the middle. Okay, so that's the first thing that goes in. Then I would really encourage you to put the load on. Now that's quite important in this instance here, and it's probably a little less important elsewhere, but actually we have to consider that this lever is going to move, so I always put the load in second. Okay, or the resistance. So I'm going to put the load there, which means in order for this to move, then the effort needs to be going down, and that's why I always go fulcrum and then I go load and then I put the effort in the end, so I just can give myself as many clues as possible if I'm struggling to remember as to which way this lever needs to go to move the load. Okay, so if I had the arrow going this way, then clearly the load's going nowhere. All right, because basically they're just fighting against each other, so it's just balancing. Well, that's not the point of the lever in this instance. Obviously you want to move the load, so we could either put the arrow at the top or the arrow can go here. So what we have essentially at this point is we've got effort, fulcrum, load. All right, effort, fulcrum, load. Now obviously we're going to talk about the different classes of lever as we go on, but what's important is we try and remember the order that it goes in. So I'm just going to give you a little bit of a kind of a strategy, if you like, to try and remember the order of these things, and it's just something that I use. Okay, it's not necessarily something that anybody else would encourage, but I'm just telling you what has worked for me in the past. English Football League. Okay, English football always touted, certainly within this country, as the premier product, okay, the best league in the world. And I know we have English Football League is that kind of championship level, but we're talking about English football here. And what I'm going to say is, and how I've always remembered it, is that English Football League is first class. Okay, it's the premier class, it's the top level of football in the world. So English Football League, first class. Okay, that's how I remember the first class lever. Now, where do we see this on the human body? Well, we only really see it in two places. First one is in the neck, okay, that nodding of the neck, so the fulcrum, that atlas and axis at the top of your cervical vertebra acts as the fulcrum, and then whichever way we have the load. If we want to bring it forward, the load's here, effort here, or if I want to bring it back here, I've got the load at the back and I've got the effort at the front, okay? But at this point here, I've got my fulcrum in the centre and my effort and load either side. All right, so that's at the neck, but probably more often you will see this, certainly in exams, is the overarm throw. Okay, so that motion. So what I have is I have the fulcrum here, I've got the load, which would be the ball in my hand, and the effort coming from the tricep to extend the arm at the elbow. Okay, so that's my first class lever, and those are the two areas of the body that you would find a first class lever. Okay, see if I can just fit it in there. Okay, second class lever. So again, we put our lever in first, and then I put the fulcrum in, which in this instance here is at the end. Okay, then I put my load, and the load is in the middle of a second class lever, which means now it enables me to recognise which way the effort needs to go, because I need to move that load, and the only way that load is going to go is going to come this way. So there's my effort arm. So I've got my effort, I've got my load, and I've got my fulcrum. Okay. So how do I remember that? Well, basically I remember the word elf, because in the North Pole, the elf is a second class citizen. The elf is the one that's always wrapping the presents, loading the sleigh, never gets any of the credit. Santa just picks it all up, goes off, he's the top dog, he gets all the applause, the pats on the back, he gets the mince pies and the glass of beer, whatever it might be, and the poor old elf is still sat there. So how have I always remembered it? The elf is a second class citizen. Elf is a second class lever. So where do we see that? Well, actually we only really see it in the ankle, and in particular, if we're using this one here, more often than not, we see it in plantar flexion. Okay, so basically when we go up onto our tiptoes. Now it's hard for me to show, and I can't do it like this, and my arm's never going to get to a full kind of 90-degree angle that we might see in our feet. But obviously here's the foot, here's the ankle here then, and here would be the gastrocnemius here, all right, from that point. So what I've got here is I've got the fulcrum at that point here as I push up, the load that's sitting on top of the fulcrum, and then I've got the gastrocnemius, which is applying the effort, okay, to point the toes. So I might see that in a netball match where a goalkeeper is attempting to mark the shot or mark the ball of a goal shooter trying to shoot, and they're up on tiptoes to try and give themselves maximum height. But at that point I would see a second class lever being involved, and that would be your only example. So now that I know what my first and second class levers are, through a pure process of elimination, I should be able to work out what my third class lever is. Okay, so once again, I put my lever in. So here I'm going to put my fulcrum in, okay, which is going to be on the end. My load sits on top. And then finally I'm going to move that load, so my arrow is going to point up. F, E for effort, L for load. Fell. However you want to remember that, it's entirely up for you. I don't have a strategy for that one, because as long as I know the first two, I can remember it. But what is really, really important as you go through all of this process is that fulcrum goes in first and then the load goes in second. It really helps me then to make sure, A, I've got the effort going the right way so I don't drop any silly marks at all, but also it enables me then to understand how the lever moves itself. And the lever then, you see this everywhere. So it might be in kicking. Okay, it can be an underarm throw. Essentially every other movement other than the overarm throw, nodding your neck or plantar flexion, you will see a third class lever being used. Okay, so those are the levers themselves. Now, before we leave this, we have got to explore the idea of something called, God, honestly, mechanical advantage and mechanical disadvantage. okay? Because each of these levers, sorry, that don't look like a capital N, but it should be. Each lever has a property that enables it to be seen as having a mechanical advantage, or it may have a mechanical disadvantage. All right, so these are really important. So let's look at a mechanical advantage first. Well, essentially, if we take, and the easiest one for me to use is going to be a second class lever. Should remember ELF, because they're a second class citizen. So I know then ELF, I'm going to have my fulcrum at this end, and then I'm going to have my load in the middle, and then I've got my effort. So I'm going to lift it. And if you can suggest that something like, it's a bit like a wheelbarrow really. But what I'm going to do, just to demonstrate the fact that we have a mechanical advantage here, is I'm just going to shift the load. Because the load in the gastrocnemius, or I beg your pardon, the load in the over the ankle, over the fulcrum, is actually sits right over the top when we go onto tiptoes. Okay, sits right over the top. Now the distance between a fulcrum and the load itself is known as the load arm or the resistance arm. Okay, that distance there is the resistance arm, or sometimes can be known as the load arm. The distance between the effort, if I can do that there, and the fulcrum is known as the effort arm. Now, if the resistance arm is shorter in distance than the effort arm, then a lever is said to have a mechanical advantage. Essentially what that means is it allows larger loads to be moved with less force. So essentially it's quite efficient. So for example, you can calf raise far greater loads, far greater weights than you can through a bicep curl, for argument's sake. Simply because the resistance arm is very short, the load is sat over it. And so if you imagine gardeners, they move huge bulk of garden materials around in a wheelbarrow because the load sits over the wheel. Now the wheel on the wheelbarrow is essentially the fulcrum, the load sits in there, and the effort is us basically picking up the wheelbarrow and shunting it. Now you would find it very, very difficult to actually carry that load itself, but because it's set in a certain way by the lever, we have that. Now the problem with a mechanical advantage, in the sense that I can produce or move an object of much greater force with less effort, is that I have a lower range of movement and I have less speed of movement. Okay, so reduced speed of movement as well. So whilst there's a mechanical advantage in the sense that I can move greater loads with less effort, I lose out in terms of range of movement and I lose out in terms of speed of movement. However, if we take something like the first class lever, sorry, my pen's kind of fading away here. Okay, so if I take my first class lever, okay, now remember it's EFL, so I've got my fulcrum here, I'm putting it here on purpose, and I've got my load here, okay, so I'm going to look at a throwing arm now, and therefore there's my effort level. Here's the effort arm. Here is the load arm or the resistance arm. And you notice now that the effort arm is much shorter than the resistance arm. Now this is a mechanical disadvantage, and it's a mechanical disadvantage because actually I am having to apply far greater force to move an object of much less weight, much less mass, I should use, rather than weight, as you know. So if we take something like a baseball, you think of the effort that a pitcher must put into throwing something that has quite low mass in order to get it moving at the speed he requires, because there's a huge amount of effort that will go into that. Now, whilst you become less efficient in moving the load in terms of the amount of effort you must put into to provide, the amount of force you must provide in order to move that load. What you do gain, as we see in terms of the picture, is the speed of movement, and you see a greater range of movement. So whilst there's a mechanical disadvantage in the fact that you are having to expend more energy to move the object, you are gaining in the speed at which you can move that object and the speed at which the lever can move and the range of movement that the lever can use as well. And that is your levers.